The Hempel Foundation Coatings Science and Technology Center, CoaST, specializes in research of fouling control coatings. Fouling control coatings are applied as the outer layer to the hull of a ship to prevent growth or to facilitate detachment of organisms that attach to the hull. The development in seaborne trade is increasing. Therefore, more innovative coatings with a sustainable profile are required by the environment as well as by the shipping industry. The problem is marine biofouling, which is the undesirable colonization of structures immersed in seawater by microorganisms, plants, and animals. The consequences of biofouling on ship hulls are high frictional resistance, higher fuel consumption, more frequent dry docking, introduction of invasive species. At Coatings Science and Technology Center, we contribute with our research and know-how to develop coatings for a better future. Two major technologies are currently prevailing within fouling control coatings. Fouling release coatings based on silicon, which are developed to repel the organisms. Conventional anti-foulings, typically based on acrylic polymers. Both technologies are applied using airless spray equipment, and the dry coating surface will rarely appear completely smooth. A smoother coating surface could be achieved by improving the leveling properties of the coating. In Coatings Science and Technology Center, a new approach has been developed to study leveling. The technique involves a combination of an automatic spiral drawdown application and a 3D measurement system based on an optical profilometer. With this macroscopic approach, a well-defined sinusoidal surface structure can be generated on the coating surface, thereby allowing the effects of important physical parameters on leveling to be studied systematically. The so-called orchard equation and the waviness parameter obtained from the 3D profilometer measurements are used to evaluate the leveling performance of wet paint. The measurements from the 3D profilometer are combined with separate measurements in an advanced rheometer. The dry coating film is evaluated using digital microscopy. Paints used in the center's research are commercial types and model paints, produced in the laboratory using high-speed dissolvers. A pilot-scale rotary setup, which contains two concentric cylinders, with the inner one being a rotating cylinder, is used to investigate the performance of fouling control coatings. Fouling control coating samples are applied to the outer surface of the inner rotating cylinder. One wall moves at a constant velocity, and the wall shear stress is comparable to that of a real ship. Torque measurements are used to estimate the drag resistance of the coated surface. The polishing and leaching performance of anti-foulings can be investigated using light optical microscopy. The final evaluation of fouling control coatings is normally done in real-life exposure. Coatings Science and Technology Center uses different sites for that purpose. Join us to invent and develop coatings for a better future.